Hello children, in the previous classes we discussed the fourth chapter. Children, as we know that fourth chapter has a 3 units. So in our channel only we discussed this fourth chapter unit wise we discussed, and even the entire chapter is discussed in 1 hour. That is one short video also which we have, children. So why I am saying means very important, children. Before going to solve the numericals, so we should have a grip on all concepts. So you better just watch those videos. Links will be given in the description. Then just come back to this video so that you can have a good practice with the numericals. Children, in this entire chapter, if you can see, numericals are based on only unit A. Because in a unit B, it is all about center of gravity. Unit C, it is all about uniform circular motion and centripetal force, centrifugal force. So from unit B, unit C, we don't have a numericals. The numericals which we have is only from unit A of this fourth chapter. So almost we have 17 to 18 numericals. So each and every numerical will be discussed in detail. But children, before going to start a numericals, let us see what are the formulas which are very important to solve the numericals. So children, here these 3 formulas which we should remember so that we can do any type of numerical from this chapter. The first one is moment of force. So moment of force is equal to force into perpendicular distance. And the second formula is couple. Couple is equal to either a force into couple arm. Hope it's clear? Fine. And the third one, children, so mostly we will expect the 4 marks numericals based on this principle of moments. Okay. So according to principle of moments, children, we all know that the sum of anti-clockwise movements are equal to the sum of clockwise movements, but in an equilibrium. That is, we can use F1 into R1 is equal to F2 into R2 when forces are given, and in some numericals weights will be given. There we can use W1 into R1 is equal to W2 into R2. So children, these 3 formulas are very important. Just copy these formulas so that we will start first numerical. Okay children, we start with the first numerical. Children, before going to solve numerical, a small thing we will do it. For any numerical, children, before going to solve any numerical, first write the data given. So if you read the data given to children, 2 points were very clear to us. First one is, we will come to know that whether all values are in same system of units or not. If not, what we have to do? We have to convert. The second thing is that, the very important thing is that, what is given, what to be calculated. If you can think about the data given and the one which you are going to calculate, so we will get a idea about the formula so that we can apply. So writing the data is very important before going to solve a numerical. So the first numerical you can see even on board also, children. So as per the question, children, it is given that the force is given, that is 10 newtons is given, force is given 10 newtons, and the moment of force is given, that is 5 newtons. So they are asking us to calculate the perpendicular distance. So to solve this numerical, children, the first formula is very important. Children, can you solve this numerical? Yes. So what you have to do, children, for every question, just pause the video, try the numerical, whether you will get or not, and try to comment your answer, then come back to the video so that you will come to know that how the numerical is solved, and you also can check whether what are the answer which you are going to get and what we are going to get here, whether matching or not. So practicing is very important. So we will today practice simultaneously, I mean the parallelly. Here I will be doing here, there you will be practicing. Hope it's very clear. Okay children, come on. So for this we have, children, moment of force is equal to force into perpendicular distance. Let us write the formula for perpendicular distance, that is tau by F. So tau is given how much, children? 5, it is 10. So 5 by 10 is how much, children? It is a 0.5 meters. So this is the answer. Did you get the same answer? Just you can cross check once again. Okay, fine. Now children, let us see the second numerical. So as per this question, children, it is given a range of length 10 centimeters. Here length means what, children? We should take as a perpendicular distance only. So R is equal to 10 centimeters is given, and also it is given, children, the force required is 5 Newton. And they are saying, they are asking us to calculate the moment of force. Children, come on, use the same formula. Pause the video. Just try it. Got it? Come on, let us see here. Children, just now I told you to write the data. So what is the benefit of writing the data? Now look at here. By seeing this very clear that force is given in SI system, open distance in a CGS system. So that to be converted, so 10 centimeters is equal to 0.1 meters. Now look at here, tau is equal to force into perpendicular distance. So this is going to be 5 into 0.1. So this is going to be 0.5 Newton meter. Children, units are also very important in our physics actually. So that makes the difference between the numericals in a mathematics and the physics. You know, in a mathematics, just getting answer is over. If you got the answer, then it's fine. But in physics, not that. We should get the answer. Simultaneously, we need to use correct unit. If not, we will use a 1 mark here only. See children, for entire numerical, it is 2 mark. Till here, you got 0.5 correct answer only. But you are just wrong with this unit. Still, you lose 1 mark. So, we must be very careful. Is that clear? Fine. Now, let us see the third numerical, children. Let us see the third numerical. So, in the third numerical, it is given, let me draw here. So, here force is given 2 Newton. Children, you should be a bit careful here. So, it is actually a given picture in a numerical. Now, children, they are asking us to calculate the moment of force about O and about A. Here, the important thing is that diameter is given. That is, children, try to understand here. AB is given. AB is equal to how much? 2 meter is given. Then what is the value of BO, children? BO is going to be radius, that is half of the diameter. Now they are asking us to calculate the moment of force about O. Children, you should be very careful. So that is force into perpendicular distance. You should take B to A only. So B to A is going to be how much, children? 1 meter. It's very important. This total is 2 meter. Then half the diameter will be 1 meter. So we should take only that is BO we should take. So this is going to be 2 into 1. This should be 2 Newton meter. This is the first part of the numerical. Now second part, they are asking us to calculate the moment of force, children, about the point A. So as about the point A, they are saying that is A is equal to force into, we should take AB because this is going to be a perpendicular distance. Hope it's clear, children? Fine. So this is 2 into 2. This is 4 Newton meter. 4 Newton meter. Okay, children, just copy it. We'll proceed. Chalo. Now we see the fourth numerical. So as per the numerical, children, so F2 is given 3 Newton, children. So this point is given as A, this point is given as a B. Children, now they are asking us to calculate the moment of force due to F1 and F2, and finally they are asking us to calculate the resultant moment of force. So children, try to understand this F1 will try to make it to rotate in a, children, what way? It's an anti-clockwise direction. So let us calculate the moment due to F1 first. So moment due to F1, let us say it as a tau 1 is equal to F1 into R1. Children, let us consider this as a R1. This you can take as R2 for sake of R convenience. So this is going to be 5 into 2. So this will be 10 Newton meter. So children, as the 10 Newton meter, you should mention whether it's a clockwise or anti-clockwise. So it is anti-clockwise, children. It is anti-clockwise moment of force. Fine. Now we also calculate the moment of force due to F2. Moment due to the F2. So that is, let us write as a F2 into R2. This is going to be, children, 3 into 4. You will get as a 12 Newton meter. So, but this 3 Newton force, children, this 3 Newton will try to make it to rotate in a clockwise. So, as per the sign convention, children, the clockwise movement is taken as a negative. So, this is going to be minus 12. Now, third bit, they are asking us to calculate the, what they are asking? Total moment, that is about O. Total moment about O is equal to tau 1 plus tau 2. So, this is going to be 10 plus of minus 12. This you can write as a 10 minus 12. This is going to be minus 2 Newton meter. So children, as we got here minus 2 Newton meter, what does it mean? the resultant moment will be in a clockwise direction only. It's a clear, children? Just try to understand the diagram, and here you need to identify which force will produce a clockwise movement and which force will produce anti-clockwise. Otherwise, too difficult to solve the numerical. I mean, you may solve the numerical, but we may not get correct answer. Why? So, taking where we should take a plus symbol, sign, where we should take a minus sign are very, very important. Okay, just copy this. We'll proceed to fifth numerical. So, here we see the fifth numerical. So, this is given, it is a 4 meter. So, children, they are asking us to calculate the resultant moment of force about this point O. So, to calculate the resultant moment, we need to calculate the individually moment given due to this force which is acting at a point A and at a point B. Then only we can calculate the resultant one. So, children, to calculate the moment of force, first we must know the perpendicular distance. Children, as A to B is a, look at here, try to understand. This is F1 force, okay? So that this you can take as R1, this you can take as R2, this you can take as F2. So let us calculate individually. Then let us see what is the resultant moment of force going to be. Okay, fine. Now children, so moment of force due to F1, let us say it as a tau 1. Tau 1 is equal to F1 into AO. That is R1 only. So this is going to be, force is given 10 newtons. 10 into this is going to be 2. This is 20 Newton meter. But children, you have to identify whether whatever the moment which we got, is it a clockwise moment or anti-clockwise. So this F1 force will try to rotate in this direction. So in this direction means obviously it is a clockwise only. So clockwise moment of force is always negative. Clear? Fine. And the second one, moment developed due to this F2, let us see. Let us name it as a tau 2 is equal to F2 into OB, that is a R2. So this is going to be a 10, OB is a 2 only. This is going to be a 20 Newton meter. But let us see whether it is a clockwise or anti-clockwise. Obviously, this 10 Newton force will try to produce clockwise moment only. As it is a clockwise moment, children, this is going to be a minus. Now, resultant they are asking about the point O, that is tau 1 plus tau 2. This is going to be minus 20 plus of minus 20. Children, minus plus into minus minus. So minus 20 and plus minus 20 is going to be a minus 40 Newton meter. So if you feel that, sir, this minus symbol is looking odd, so you also can write like this: 40 Newton meter. In a bracket, you should write clockwise. Children, this is very, very important. Either you should mention clockwise or you should mention the negative symbol. Is it clear? Just copy this fifth numerical, then we'll go for 6th and 7th. Let us see the 6th numerical. And this is the middle point O is given. So children, so as per the question, so they're asking us to calculate the resultant moment. So due to point A and point B and about this point O also. Children, it seems to be a bit complicated, but this is the easiest numerical. So what are the methods which we followed in the previously, children? Same methods only, but little bit you should be bit careful so that we can get the correct answer. Now children, first they are asking moment of force about this point A. So first let us write moment of force due to point A is equal to force into perpendicular distance. Formula is not going to change. Formula is the same for all numericals as I told you. Okay, fine. Now force is how much? 20 Newton. Sorry, 10 Newton it is. 10 Newton. But the question is that R means how much we should take here. It's very, very important. About this point A, this is a force acting. This is a force because this is going to be a pivot point. So from here to here, 50 centimeter. Here also very important. So R is given 50 centimeters. That is how much, children? This is 0.5 meter. So we should take 0.5 meter. It's very important. So due to this point A, let us say A is a pivot point and this force will produce a moment. So this is going to be 10 into 0.5. It will be 5 Newton meter. But thing is that, is it a clockwise or anti-clockwise? About this point, pivot point A, children, this force acting in this direction. So, this will produce clockwise only. As I told you, clockwise moment is negative. Children, here you can write minus 5 Newton meter, or if you don't want to write a minus symbol in bracket, you must mention it as a clockwise only. Is it clear? Fine. Now, children, so moment of force about the point B. Now, point B is going to be a pivot point. Now, let us see this force is acting. So, here that is force into perpendicular, same thing. So, due to this point B, children, about this point B, what is the force acting here? 10 newtons. That is 10 newtons. And perpendicular distance is not going to change, same thing. That is 0.5 only. So, this is going to be 5 Newton meter. Now, let us check about this point B. This force will produce clockwise or anti-clockwise. It's acting in this direction. So, you will try to rotate in this direction only. That is, this force also will produce clockwise movement. So, that is going to be minus. Now, children, they are asking about the resultant movement about this point O. So, very important. So, look at here. About this point O means in two phases we have to do it. Two phases we have to. Let me do here. So, we need a space actually, children. So, now this is going to be 0.25 meters, very important. This perpendicular distance is going to be 0.25 meters. Why I am saying about this point O, two forces we need to consider. I mean, it's very, very important. Two forces we need to consider. Means, look at the third one. If you want to calculate the resultant movement about this point O, first we need to calculate the moment of force due to this force which is acting at a point A. Again, you need to calculate the moment of force due to the force which is acting at a B. Then we have to add. We have to add so as to get the resultant moment about point O. So, now children, look at here. So, this is, let us say, the this distance, let us say, is the x, children. This perpendicular, let us say, y, to have a good clarity. So, now moment of force, like about O to this, let us say it's a tau1 is equal to force acting at a point A into x. So, this is going to be 10 into 0.25, children. So, this you will get 2.5 Newton meter. If you can notice, the force which is acting at a point A will produce a clockwise movement. It is going to be negative. Okay. Now, let us see the moment of force, okay, about this point O due to this force acting at a point B. Let us say it as the force acting at a point B into y. So, this is going to be 10 into 0.25. So, this is going to be 2.5 Newton meter. Children, as usual, the force acting at a point B will produce clockwise movement. It is a negative only. Now, they are asking resultant about this point O. So, this we have to do tau1 plus tau2. This is going to be minus 2.5 plus of minus 2.5. This will be minus 2.5 minus 2.5. This is going to be minus 5 Newton meter. As I told you, if you don't want to write the minus symbol, simply you can write 5 Newton meter in bracket. What we should write, children? It is clockwise. It is clockwise. Is it clear? Fine, just copy it. Fine, children. Here, let us see the seventh numerical. So, children, as per the numerical given, children, it is given that a steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying the two forces, each of magnitude 5 newtons. So, let us take a steering wheel. Steering wheel means let us take a circle only. We are not going to draw exactly steering wheel. Fine. Let us say its diameter, they are saying that diameter is 5 meters at this point O. So, to make it to rotate in anti-clockwise direction, how the two forces should act? Yes, let us say the point B, the 5 Newton force is acting here. This is 5 Newton force, and the force, let us say it's A, so it should act 5 meters like this, 5 Newton, sorry. So that what will happen? It is rotated in a anti-clockwise direction. Now they are asking us to calculate the resultant or the movement about this point O. Children, again individually we have to calculate. So this is going to be perpendicular distance. How much, children? This is going to be 2.5 meter. Hope it's clear. Fine. And what is given? Is it 5 meters? So this is 0.5. Oh my god, 0.5. Then as diameter is 0.5, this is going to be 0.25 meter, and this is also going to be perpendicular distance 0.25 meter. Clear? Come on children, let us do fatafat, we can do it. So here moment of force due to point A is going to be force into AO. So this is going to be 5 into 0.25. So 5 into 0.25, how much it will be? Come on, 0.125. Yes, 0.125. Check once. Or 1.25. It's a 1.25. So this is going to be a 1.25 Newton meter. So children, it's anti-clockwise, is a positive only. No to mention plus. Okay, fine. Now moment of force due to 5 Newton at a point B is going to be F into OB. So this is also children 5 into 0.25. This is going to be 1.25 Newton meter. Now we need a total moment children. Total moment resultant. Oh, that is tau A plus tau B children. So if you can add 1.25 plus 1.25, you are going to get a 2.5 Newton meter. Children, you should write as a anti-clockwise. Finally, whatever we are getting is a anti-clockwise moment only. Okay children, so in this question they asked us to draw the diagram at the same time they asked us to calculate the resultant moment about point O. Clear? Just copy it. Now children, let us see the 8th one. So numerical is given on screen. Just go through it, pause the video and check the solution. Come on. So as per the question children, it is given a uniform meter rule. Children, uniform meter rule means it's very clear, this is a 0 centimeter, another end will be 100 centimeter. It is said that it is pivoted exactly at midpoint children. Midpoint means where? 50 centimeter mark. It is said that 50 gram force is suspended at one of its ends. Either you can take a left side or right side. Nothing is wrong. So let me take here. Here it is 50 gram force. This is how much it is a 50 gram force is weight. So obviously now if it is a situation children, do you think that it is balanced? Obviously no. It will try to rotate in anti-clockwise direction. Now they are saying that where should a weight of 100 gram force is suspended to keep a roll horizontally? Means somewhere, obviously it is the right side of the 50 centimeter mark only. Somewhere else, let us say this is a point where this 100 gram force weight is suspended. So let us say this distance is x, this to be calculated. Okay, so this is going to be how much children? This is going to be obviously the 50 centimeter. Now let us write the data children. So let us say it is a W1 is 50 gram force and here R1 is 50 centimeter. So W2 is 100 gram force. Fine, R2 is x, that to be calculated. Children, come on, let us apply the principle of moments of weights. Come on, just pause the video, try it. Did you get it? Got it? Try it. 3, 2, 1. Chalo. So according to children, you should write into R2. So this is going to be 100 in 50, right? Okay, let us follow as this. 50 into 50 is equal to 100 into x. Here you may get one doubt. Sir, here distance is given centimeters. Shouldn't we convert it to meters? Not required, because weight also given gram force. So no problem at all. Okay, fine. So now 0, 0, 0, 0. 5 was 25. X is equal to 25 centimeters. Oh my god, what is this? You may get one doubt. So 25 centimeters means here only. But how it is balanced? Yes. 25 centimeters from the pivot point towards right side. Means this is 50 plus 25. Means this mark is at a 75 centimeter. So x is equal to 25 centimeters from pivot point. Pivot point, very important. You should write this towards right side. Children, writing this is mandatory. Otherwise, it is not understood clearly. 25, it's not a 25 centimeter mark. I'm not saying that we got 25 centimeter mark. No, 25 centimeters from this pivot point. So 50 plus 25 is at 75 centimeters. Hope it's clear. Just copy it. Now we'll go to the, so numerically it is clear. Now we go to the ninth numerical. Children, this ninth numerical is the most wanted. Okay, na? It's clear. So you can look at the numerical there. Come on, as usual, pause the video and try the numerical. So just try to comment your answer, how much you are going to get. Children, again I'm telling you, whenever you are solving a numerical, have a confidence, have a faith in you. It is not that whether you are going to right answer or wrong answer. Don't think about result. Just think about the method, whether you are going to follow the method or not. First, read the question properly. If you can read the question properly, then you can understand. Once you can understand the numerical, children, you can apply the concepts, whatever you know with the proper formula, then you will get the correct answer. Chalo, shall we do it? Come on. So here is the ninth numerical. So as per the question given, children, it is also uniform meter rule. Uniform meter rule. So let us make it as properly. Uniform meter rule. Children, it is a uniform meter means it is not required that we should draw 1 meter scale, 1 meter length, not required. So let us say 0 and it is a 100 centimeter. Children, it is said that actually this uniform meter rule is a pivot at a 58 centimeter mark. So 58 means little bit right side only it will be. So this will be 58 centimeter mark. Children, now look at here. Do you think that now it will be balanced? Obviously no, because left side length is more than the right side. As it is, they said that it's a uniform meter rule, mass is distributed uniformly. Obviously this side weight will be more than this. So obviously what will happen, we'll try to read in an anti-clockwise direction. Now they are saying to make it horizontal, children, they are asking us to add 20 gram force. Is the 20 gram force? Let me check once again. Yes, 20 gram force is suspended. At one of its ends, they are not giving information whether we should add left side or right side. It is our common sense, children. As it is trying to go, so in this direction, which side we should add? Obviously, right side it to be added. Okay, na? So at this end, so here only right side, children, that 20 gram force to be suspended. Such that this perpendicular distance is going to be 42 centimeters, children. 42 centimeters. Children, as it is a uniform meter rule, children, its weight will act exactly at its center of gravity. You may get one doubt, sir, what is the center of gravity? Yes, it is discussed in detail, and regarding center of gravity, link is given in description. Just you go through this if you have any doubt regarding the center of gravity. For a uniform meter rule, children, center of gravity will act exactly at its midpoint. Midpoint means how much? 50 centimeter mark. So this is a point where the total weight of the meter rule will act. Now children, this perpendicular distance going to be 58 minus 50. This is going to be 8 centimeters. So children, this is the diagram required. Now they are asking us to calculate the weight of the meter rule. It's very simple. Now let us read the data. Let us say W1 is a W that to be calculated. Let us say R1 is 8 centimeters and W2 is going to be 20 gram force, and here R2 is going to be 42 centimeters. Now let us apply according to principle of moments of weights. According to principle of moments of weights, we can write here W1 into R1 is equal to W2 into R2. So let us W1 is how much? That to be calculated, W into 8 is equal to 20 into 42. Now look at here, this is going to be 20 into 42 by it is 8. So 4 2s are 4, 5s are 2 1s are 2, 21s. So 21 into 5 is going to be 105 gram force. This is how we can calculate the numerical in simple manner. Children, if this is not correct, if you won't get a correct diagram, obviously you won't get a correct solution. So again I'm telling you, read the question at least twice to understand it, then make a diagram. So based on this diagram only, we can solve the numerical. Is that clear? Just copy it. So children, here as per the numerical 10, what is given? It's already uniform meter rule is given. So this is pivot point. So left side it is a 50 and it is a 50 mark. So this is 0, 50, 50. So that is a 1 meter only. So it is said that children, so the weight of 40 gram force is placed at a distance of 40 centimeter to the left. So left side 40 means this is a 40. At a 40 centimeter mark, here 40 gram force. Here 40 gram force is placed. So this is going to be how much, children? Obviously 40 centimeters is going to be. Next, how can you balance the bar with a weight of 80 gram force? So obviously it is not a balance. It will try to rotate it anti-clockwise direction. Now we need to put that weight of 80 gram force right side, but they are asking where that to be placed. So this x, let us say it's x, to be calculated. So let us write the data given, children.
So let us say W1 is equal to 40 gram force and R1 is equal to 40 centimeter. Now W2 is equal to, so it is 80 gram force. Now R2 is x, that is to be calculated.
Now children, according to principle of moments of weights, again it's the same concept, that is W1 into R1 is equal to W2 into R2. So let us substitute the values. It is 40 into 40 is equal to 80 into x. 0, 0 cancel. So 4 ones are 4 twos are 2 ones are 2 20s are. So x is equal to 20 centimeter, which means what, children, then that 80 gram force weight should be placed 20 centimeters from this pivot point. This is a very important. So right side, where, children, it is a 20 centimeters. Just copy it, children, then we will proceed. Yeah, children, look at the 11th numerical. It's a very important, children. So as per this question, children, don't get confused. If you read the question without seeing the diagram, we may get confused actually. So it is let us say 0, it is 50 centimeter mark, and it is 100 centimeter mark. So they are saying that at midpoint it is pivoted. Okay, midpoint is pivoted, and at a 10 centimeter mark, children, at a 10 centimeter mark, here 40 gram force. This is how much? 40 gram force is suspended. So that this perpendicular distance is how much, children? It is going to be a 40 centimeters. Now the thing is that, and the weight of 20 gram force at a 90 centimeter. So 90 centimeter mark going to be this 90 centimeter mark. Here a weight of 20 gram force is suspended. 20 gram force. So this will be how much, children? Obviously this will be 40 centimeters. So this is what actually the given diagram. The first question is that, is the meter rule in equilibrium or not? So children, if you want to say whether it is in equilibrium or not, first we should know whether anti-clockwise movements are equal to clockwise movements. So let us calculate, children. So this will produce anti-clockwise movement. Let us say tau 1 is equal to 40 gram force into 40 centimeter. This is going to be 1600 gram force centimeter. Now let us say tau 2 is due to the 20 gram force, that is the clockwise moments of weights. This is going to be, what is the weight? 20 into 40. So this is going to be 800 gram force centimeters. Children, obviously anti-clockwise movements are greater than the clockwise movements. Obviously it is not balanced. It is not balanced. It's very clear. It is a not balanced. Okay, fine. Now the second part, what they are asking. So then how can the rule be brought? So okay, fine. So this is what actually not balanced. Then in which direction it will have moment, children? As anti-clockwise is greater than the clockwise, so it will have anti-clockwise movement. It will have anti-clockwise movement. Anti-clockwise movement. This is the first question. Fine. And the second part of this question, what they are asking, children? It is asked, so how can the rule be brought in equilibrium by using additional weight of 40 gram force? Children, they are asking us to take 40 gram force weight and keep somewhere, but finally make it balance, they are saying. Children, as it is trying to tilt in anti-clockwise direction, obviously which side the 40 gram force should be added? Obviously it is the right side, but we don't know where it is. Let us say somewhere else. At x distance, let us say at x distance, this 40 gram force is added. 40 gram force is added. Now children, so according to principle of moments of weight, children, anti-clockwise moments are equal to sum of the clockwise moments of weights. So that is, let us say this 40 gram force now will produce clockwise direction. Let us say it is a tau 3. Try to understand tau 3. So as per the principle of moments of weights, tau 1 is equal to tau 2 plus tau 3. So tau 1 we calculated, that is 1600 is equal to 800 plus tau 3 is equal to how much, children? We don't know distance. So 40 gram force into x, 40x. So this is going to be 40x is equal to 1600 minus 800. This is going to be a 800. So 40x is equal to 800, children. So x is equal to, it is 20 centimeter. Means from pivot point is 20 centimeter. Try to understand. From this 50 centimeter mark, this is 20 centimeter. I mean what? Where this 40 gram force should be placed? At 70 centimeters. Try to understand. 20 centimeters from pivot point right side. So 50 plus 20, it is going to be 70 centimeters. Okay, children? Just copy it. Fine. Numerical 12. Is it numerical 12 or 11? Let me check once. So, yeah, it's a numerical 12, children. So, let us say it is seesaw. Let us say it's a midpoint O. This total length is given 4 meters, children. It is given 4 meters. Now, they are saying that at one end, the boy of what we can say 20 gram force, 20 gram force, 20, so not 20 gram force, is a 20 kgf, 20 kgf is sitting at one end. Obviously, it won't be balanced. So, to make it balanced, where a person of weight 40 kgf should sit, means of course, obviously, right side only he has to sit here. So, it's a man of 40 kgf. Now, they are asking us to calculate this x, where he should sit from this pivot right side, that is x, that the x distance we need to calculate. Children, this is going to be how much, children? This is going to be a 2 meters. Now, let us read the data. So, here W1 is equal to 20 kgf and here R1 is going to be a 2 meter and here W2 is equal to 40 kgf and R2, that is x, to be calculated. Now, let us apply the same concept, principle of moments of weights. According to principle of moments of weight, children, that is W1 into R1 is equal to W2 into R2. Now, let us substitute 20 into 2 is equal to 40 into x. So, 22 is a 40, 40 cancel, that is x is equal to 1 meter. Children, x is equal to 1 meter means what? From pivot point, he should sit at a 1 meter, means what? At a 3rd meter. Am I clear? 2 meter, 3 means what here? From this pivot point, he should sit at a 1 meter distance right side in order to make it balance. Is it clear? Children, if you can see, in all numericals, the concept is very clear, just we are applying the principle of moments. That's what I said. If you are okay with that principle of moments, children, each and every numerical is very easy. You can play with all numericals. Got it? Just copy it. We'll go to the 13th numerical. Come on. Fine, children. Now, let us see. This 13th numerical is based on physical balance. So, it is given that a physical balance has arms at, this is 60 centimeters. One is a long arm it has, another one is a 40 centimeters, that is short arm it has. So, let us draw this rough diagram. So, children, actually diagram is not required. For the diagram, you don't have any marks actually in exam, but the thing is that we get a grip. Am I clear? Fine. So, it is said that a physical balance, it arms of length 60 centimeters and 40 centimeters. Okay. What weight kept on the pan of the longer arm will balance an object of weight 100 gram force kept on the the short arm, children. So, here they are saying 100 gram force weight is placed. Now, they are saying in order to balance this here, how much weight are you going to keep? It's very simple. So, let us say it's a W1 is question mark So R1 is very clear from the diagram, it is 60 centimeters. So W2 is equal to 100 gram force. Now R2 is equal to 40 centimeters. Children, let us apply the same concept and let us calculate. Come on, pause the video. Just try it. I mean, just simplifying. Okay, trying. Got it? 3, 2, 1, go. So here, according to principle of moments of weights, children, here we can write here W1 into R1 is equal to W2 into R2. So as we need to calculate W1 is equal to W2 into R2 by it is R1. So W2 is how much, children? It is 100 into R2 is 40 by it is how much? 60. 0, 0 cancel, 4 2s are, sorry, 2 2s are, 2 3s are. This is 300 by, sorry, it's a 200, not 300. So 200 by 3. So children, if you can simplify, approximately you can get 66, sorry, yeah, 66.666, that we can get 66.67 gram force. I mean 66.67 gram force weight should be placed in a pan of long arm in order to balance this situation. Is it clear, children? Just copy it. Children, it is the 14th numerical. This is a point O. So children, this is actually a diagram which is given in the question. That is numerical. Now they are asking us to calculate the total anti-clockwise movements of weights and the total clockwise movements of weights and the difference between two. And if it is not balanced, then how you are going to balance it? By keeping the 100 gram force on this meter rule. So let us see here. So first, children, here anti-clockwise movement they are asking. So first we need to calculate the anti-clockwise movement. Anti-clockwise movement, let us say, so it is a tau 1. Children, here this 150 gram force weight will produce anti-clockwise movement. So now directly let us apply formula. So that is 150 into 40 centimeter mark. It is a 40 centimeter mark. So this is going to be 6000 gram force centimeter. This is an anti-clockwise, children. Now we need to calculate the clockwise movement. This is clockwise movement. So this is produced by a weight of 250 gram force. This will try to produce a clockwise movement. So as per that, it's a W2 is equal to 250 into it is a 20. So this is going to be a 5000 gram force centimeter. Children, it's very clear that your anti-clockwise movements are not equal to the clockwise movements of weight. So obviously it is not balanced, and the resultant movement will be anti-clockwise only. Now they are asking us to find difference. Children, this is going to be a minus. Why? Clock movement is always a minus. Now difference they are asking here. Difference, children. So 6000 minus 5000. See, children, some students may get doubt here. 6000 minus of minus 5000 they'll do. No, don't do like that. Your minus represents to say that it is a clockwise only. So difference is how much? It is a 6000. Here is a 5000. So the difference is simply 6000 minus 5000 is going to be a 1000 gram force. So this 1000 gram force is what, children? It is the anti-clockwise, children. This is anti-clockwise. Means what? As a result, the total meter roll will try to rotate in this direction. Now the thing is that they are asking us to use 100 gram force in order to balance. So that 100 gram force, where are you going to keep? So right side you have to place. We don't know whether here, 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 here. That we need to calculate. Let us suppose it is placed here, let us say. So here we are going to place a 100 gram force at a distance of x. This x actually to be calculated. Now let us apply the principle of moments. According to principle of moments of weights, anti-clockwise movements of weights are equal to the clockwise movements of weights. Now children, the total anti-clockwise movements of weights we got 6000 is equal to, clockwise means due to 250 grams already we calculated the 5000 plus this is 100 into x. This is 100 into x. So this is going to be 100 into x is equal to 1000. So x is equal to 10 centimeter. Children, 10 centimeters right side right side of pivoted point. Pivoted points, very important. Writing this point is very important. Directly you cannot say just x is equal to 10 centimeters, but where the 10 centimeters is going to be, that 10 centimeters is right side from this pivot point actually. So this is going to be a 10 centimeter mark. So 0, this axis value is going to be 10 centimeters. So if we can place that 100 gram force weight at a 10 centimeter from this pivot point right side, then what will happen? That meter rule is balanced. Children, again I am telling you, concept is only based on a single concept, almost all numericals which we have. But the thing is that how you are going to understand the numerical is a very important. Okay, just copy it. So here 15th numerical is given, children. It is given that a uniform meter rule of weight. Okay, uniform meter rule, let us say 0 to 100 centimeter. So here uniform meter rule. Weight, children, for this uniform meter rule, where the weight will act? Exactly at 50 centimeter mark. So the weight is given, children, how much? 10 gram force. Okay. Now it is pivoted at its 0 mark. Okay. So this is a point where it is pivoted. That's fine. Okay. Now they are asking what moment of force depresses the rule. So obviously try to understand this due to this 10 gram force. So it will try to depress downward direction. That is what it will try to depress, means what? It's a clockwise moment of weight is produced. So that how much and in which direction we need to calculate. Children, this perpendicular distance is how much? It is 50 centimeters. Come on. Then let us calculate. Tau is equal to weight 10 into perpendicular distance is 50. So this is going to be a 500 gram force. So 500 gram force is a clockwise, children. Try to understand. It is a clockwise direction. It is produced. This is the first question. The second question they are asking, children, how can it be made horizontally? By applying a least force. So it will try to depress in a downward direction. But how are you going to make it horizontal? For that we need to apply the least force. Children, here we need to recall the concept. How where force is related to the perpendicular distance. Children, more the perpendicular distance, less the force. Less the perpendicular distance, more is the force required. Now they are saying us to apply the least force. Least force means at this end only. So here how much force are you going to apply to keep it balanced? For this, children, what is the perpendicular distance? You should take perpendicular distance from here. It is going to be 100 centimeters. So we need to calculate a F value. Come on, this is the first part. Now second part, children, tau is equal to F into R. Already moment of force how much we got? 500. 500 is equal to F to be calculated. R value is how much? 100 centimeter. So F is equal to the 5 gram force to be applied vertically upwards. So this much least force is required in order to make it balance. Is it clear? Just come on. Children, here let us see the 16th numerical. So here don't get confused, children. This numerical is based on half meter rule. So here half meter rule means we should take here is 0 to 50 centimeter. Fine. Now they are saying that it is a pivoted at a 29 centimeter mark. So 29 centimeter mark is this side, 29 centimeter mark. Now children, do you think that is a balance? No, it is not balanced. Now they are asking us to add a 20 gram mass from one of its ends. Obviously, children, so that 20 gram to be added right side only in order to balance it. In order to balance it. So this perpendicular distance is going to be how much it is? I think 21 centimeter. Now they are asking us to draw a diagram and find the mass of the meter rule. Children, as it is a uniform meter rule, its mass will act here. We know that its weight will act here. Weight will act. Actually, it's a mass also will act. So this to be calculated. So then this distance is going to be how much, children? This is a 25 centimeter mark. Obviously, this is a 4 centimeter mark only. Children, let us apply the principle of moments of weights. So here I can apply this one, children. W1 into R1 is equal to W2 into R2. Here you may get one doubt. Sir, you are taking the weights, but it is in terms of mass. Yes, children. We know that W is equal to mg, right? So we know W is equal to mg. Now let us rewrite that. So in the place of W1 I can write W1 is the total weight. Then this is going to be mg into R1 is going to be mg into R2. G cancel. So here R1 is equal to 4 centimeters. Small m is given 20 grams. And R2 is going to be 21 centimeter. Now let us substitute, you will get it. So capital M into 4 is equal to 20 into 21. 4 ones are, it is 4 fives are. So capital M, it is going to be 105 grams. Hope it's clear? Fine. This is the second part. Now third part is there, children. In which direction would the balancing point shift if 20 gram mass is shifted inside from its one end? So they are saying, children, if this 20 gram force is, children, this is shifted inside, then they are asking us to find in which direction would the balancing point. Balancing point means what, children? Here 29 centimeter mark. Children, try to understand. As you are decreasing the perpendicular distance in order to make it balance, the 29 centimeter mark also should move inside, that is inward only. That balancing point also should move inside only, that is towards 25 centimeters. Because as you are decreasing the perpendicular distance, this perpendicular distance also should be decreased so that it is in balancing condition. So it's minimum common, we should think with the common sense only. Here you are decreasing, you are pushing this inside means what? This 21 centimeter is going to be decreased. Then obviously this 4 centimeters should be decreased. It happens only this pivot point is shifted towards 25 centimeter mark. Is it clear? Clear? Think once, understand, then copy it. Let us see the 17th numerical, children. Let us see the 17th numerical. As it is given, again it is a uniform meter rule of mass 100 gram. So look at it, children. It is a uniform meter rule, that is 0 to, let us take a lengthy one only, 100 centimeter. It is given that, children, its mass is 100 gram. Children, for a uniform meter rule, where its total mass will act, children? The total mass will act exactly at a midpoint. That is at a 50 centimeter mark, the total mass will act. How much it is given? 100 grams. That's fine. Is a balance on a fulcrum at a 40 centimeter mark. So fulcrum is placed at a 40 centimeter mark. 40 centimeter mark by suspending an unknown mass small m at a mark 20 centimeter. So here at a 20 centimeter mark, children, here they are saying a small m is suspended as such that it is balanced. So now you can understand what is going to be asked. They are going to be asked this unknown mass. Let us calculate first. So this is going to be how much is a 20 centimeters perpendicular distance, and this is going to be a 10 centimeters. Is it clear? Fine. Now let us apply the same concept, principle of moments of weights. According to that, can we write like this? M into 20 is equal to 10 into 100. Yes. 0 cancel, 2 ones are 2 50s are. So M is equal to 50 gram mass to be placed at a 20 centimeter mark in order to make it a balance. Fine. Now question 2. To which side the rule will tilt? Now it is balanced, children. If the mass M is moved to the mark 10 centimeter. Oh my God. So this is the first question, children. Now they are saying, so let us make a diagram for that also. Wait. This is a point where they are asking us to shift the 50 gram mass. Now, children, obviously, as we are increasing the perpendicular distance, do you think that it will be balanced? Obviously, no. So this side perpendicular distance increase. Obviously, it will try to tilt in an anti-clockwise direction. Now, they are asking us to calculate the resultant moment, children. Resultant moment. Children, as mass is 50 gram, obviously, the weight is going to be 50 gram force. Very important. It's a 50 gram force. So if the mass is 100 gram, children, the weight is going to be, let us say W1. The weight W1 is going to be a 100 gram force. Now let us calculate the tau 1. This is anti-clockwise movement. Due to this 100 gram force, you will get a tau 2 moment. So tau 1 is equal, children, this is going to be a 50 into 30. This is going to be a 1500 gram force centimeters, which is anti-clockwise direction. So it is the positive only. Tau 2 is, children, due to this 100 gram mass, that is 100 gram force weight. So that is 100 gram force weight into popping distance is going to be 10 only. This is 1000 gram force centimeters. It is going to be negative. Why negative I am saying, children? This is clockwise movement. Clockwise movement is taken as negative. Now resultant one, children. Resultant one is equal to tau 1 plus tau 2. This is 1500 minus 1000. So it is going to be a 500 gram force centimeter. So this is a resultant. This is a resultant movement. As we got a positive, children, it is anti-clockwise only. It is anti-clockwise movement. Okay, now fine. So, and one more thing here, question is not over yet. So children, this is a third part if I am not wrong. So this is third part actually. This is third part and this is a second part. This is the first part. Fourth part is there. How can it be balanced by another mass of 50 gram force? Okay. Now they are saying, look at here, this is the fourth one. How are you going to make it a balance by using a 50 gram force? Children, in result what is happening? It is trying to tilt in anti-clockwise direction. Obviously, the 50 gram weight to be added right side only. But where are you going to add? Where are you going to add? It's very simple. Let us use the same concept. Sum of anti-clockwise moments are equal to sum of the clockwise moments. So anti-clockwise moments already we calculated, that is 1500. That is 1500 is equal to, due to this 100 gram force weight already we got 1000 plus, now this 50 gram force, this distance let us say the x. Oh, from where? From pivot point. From pivot point let us say the x. 50 gram force. So that is 50x. So children, the 50x is equal to 500. So let us simplify this. 50x is equal to 500. So x is equal to 10 centimeter. So x is equal to 10 centimeters from where? From this pivot point. From x is equal to 10 centimeters, 40 plus 50 centimeters. Which means what? Therefore, 50 gram force is suspended at 50 centimeter mark only. Centimeter mark. Am I clear? So children, this seems to be lengthy, but once or twice if you can practice, it become very easy only. So in these kind of numerical, children, so there will be a chance of getting confused. So you should be a bit careful. Okay, now just copy it. Okay. Okay, children, have you copied? Copied? Shall I up? 3, 2, 1, go. So children, now we have come to the end. I mean, the last numerical is there. That is the 18th numerical. So with this, we are going to finish all numericals from this first chapter. So what is that question given, children? So here, question diagram is given. It is the 18th one, children. And from here to here, it is L by 2 only. Okay, na? Fine. Now let us see what actually question is. So uniform power of length m is suspended at ends. Okay, wait, middle point. In equilibrium, find the reactions R1 and R2 at the ends. So very clear, R1 R2 values they are asking, children. It's very clear that they are balanced, which means what, children? In equilibrium, it's very important to understand. In equilibrium, children, can I write W is equal to R1 plus R2? Yeah. We can write here R1 into L by 2 is equal to R2 into L by 2 in a balancing condition, which means what, here we are getting R1 is equal to R2. So R1 is equal to R2 is equal to, can I write R? Okay, no problem. Here you can substitute, that is W is equal to R1 plus R1, that is 2R1. As W is equal to 2R1, R1 is equal to how much, children? W by 2, even which is equal to R2 also. Hope it's clear. So this is what actually, so R1 is equal to, R2 is equal to, so if you want to, so you can write KGF because W is given KGF. So answer also going to be in KGF only. Okay, children. So these are the numericals based on the fourth chapter. Children, again I am telling you, every time I will tell you, the very important thing which we all should follow is that textbook reading is a mandatory. Again I am telling you, first go through the textbook, children. Then You can take a help of any material or any videos. It's very, very important. And first read the theory part, children. Again, I'm telling you, before going to watch this video, you should have watched already the theory concept which are covered in our, what we can say, in a channel only. The links will be given in description. Just go through that so that you will get a even grip on the concepts also. Okay, children. And after that, just you practice a numerical. Children, once again, I'm telling you, just not one time, just let us read that second time also numerical. Nothing is wrong actually. Read the numerical until you understand. Once you can understand, it's a very easy to solve the numerical. The thing is that we are in a hurry to complete the reading part. It is not that. Read, understand, then start solving. Then obviously you will get the, what we can say, answer perfectly. Okay, children. Thank you so much. All the very best.